Alright, so for lesson 78, we're going to take a look at something that might be new to you, powers and exponents. So you've been dealing with different operations for numbers, addition, subtraction, multiplication, division. It's time to take a look at a new one, yet another one that's going to be related to something you know. So let's consider the pattern from a previous investigation: 4, 12, 36, 108, 324. And then I put the dot, dot, dot to show that that's going to continue on. What is the pattern? Pause it, try to figure that out. Well, if you look at 4 to 12, that could be plus 8. But if you do plus 8 again, that's not going to be 36. So that teaches us that it is not an arithmetic pattern, not an arithmetic sequence. So you're not adding or subtracting, it must be multiplying. What can we multiply 4 by to get 12? 3. And I made a misspoke. It might not even be multiplying, but in this case, to keep it simple, I did a multiplying pattern. Times 3, did that work? Yep. Try it again. Times 3, does that work? Times 3. Maybe take you a minute to check. Yes, it does. Times 3. Okay. The pattern is multiply or multiplying by 3. And so we are repeatedly multiplying by 3. Maybe you remember, maybe when you first learned about multiplication, that was the process of repeatedly adding a number. For example, just a quick recap here. If we had, let's say we had 5, 10, 15, 20, 25. What we're doing here, we're just adding 5 every time. I've added 5 once to 0. I've added 5 twice. I've added 5 3 times. I've added 5 4 times. Or what you might consider is 5 times 1, 5 times 2, 5 times 3. And I think you can probably figure out where I'm going with this. You see, multiplication is just repeated addition, repeatedly adding 5. Well, what would happen if we repeatedly multiplied by something? So in this first example, we're repeatedly multiplying by 3. So what I'm going to have you think about is, well, this is 4 times 3 one time. No, actually, that's not 4 times 3 any times, is it? So that's just 4. But this is 4 times 3 one time. How could you write that for 36? So, again, let me translate this pattern down here a little bit. We have 4, 12, 36, 108, 324. Any of these numbers, we're not really going to go too in depth with the large numbers, but the smaller numbers can teach us everything we need to know. And at the number 4, the beginning number, I really haven't multiplied by 3 any, so let's just call that 4. I know, crazy. Here, though, we're saying 4 times 3. I took my last number and I multiplied by 3. Well, then this one, that was like 12 times 3, right? But where did I get the 12 from? Well, that was really 4 times 3 again, and then we have the times 3 here. Let's see if I have any highlighters. I must have left those. So here's what I really want you to see. This 12 was really this 4 by 3. Well, what would happen here? Well, I multiplied the 36 times 108, didn't I? 36 times 108. Where did I get the 36 from? 12 times 3 times, I'm sorry, not 108. Whoa, times 3. Slow down a little bit here, sir. So that's really just a 3. I know it doesn't look like it, but there's a 3. That was really a 12 times 3 to get the 36, and then we had this 3. Well, where'd this 12 come from? That was the 4 times 3. And then we had a times 3 here, and a times 3 here. Hopefully you're starting to get, throughout some of this messy writing I have, they were just multiplied by 3 over and over again. So what are we supposed to do with that? I mean, do we have to keep writing the 3? You can probably tell that this next one is going to be 4 times 3 times 3 times 3 times 3. Oh, man. There must be a simpler way. Some of you like to write. Most of us are going to get tired hands if we have to keep doing this pattern. So what I'm trying to introduce to you is a way to write repeated multiplication and a notation for it. So that notation is going to look like this. We're going to have 4, we can have times 3 to the 1, 2, 3, fourth power. Why did I choose 4? Because there's 1, 2, 3, 4 different 3's here. Apparently I have company. Alright, must have been FedEx. So, in this next pattern, let's observe and let's see how that shows up. Okay, let's see how that shows up. So 2, 4, 8, 16, 32. Can you continue the pattern for me? If you've identified the pattern, or pause it to make sure you can, we are just multiplying by 2 over and over again. Times 2, times 2, times 2, times 2. What's 32 times 2? 64. Times 2 again. 128. Times 2 again. Stop and make sure you can get it. 256. Well, let's think about something. 2 is just 2. It's a prime number, which we'll talk a lot more about in 6th grade. There's not really anything I can multiply 2 by to get to 2 other than 1. So it's just itself. But 4 can be rewritten as 2 times 2, right? And if we learned anything from this little snippet here, then this means I can rewrite this as 2 to the 2nd power. Again, that notation with the little 2, notice it's smaller and it's up high and to the right. That is what an exponent is going to look like. That's what's going on here. So I have 2 to the 2nd here. We'll come back to the first one here. What about 8? Well, you know, I could write that as 4 times 2. Well, you just told me that 4 can be written as 2 times 2. So at that point, I would have 1, 2, 3 2's, which is going to be 2 to the 3rd power. 2 to the 3rd power. Can you figure out what 16 would be rewritten as? Well, if you know that 8 times 2 is 16, and 8 is already 2 to the 3rd, then it should make sense that 16 is going to be 2 times 2 times 2 times 2, or as we're learning to write, 2 to the 4th power. So, what does this mean for us? This means we can represent this pattern. That 8 is 2 to the 3rd, that 16 is 2 to the 4th, that 32 would be 2 to the what? 2 to the 5th. Well, if we work backwards, what must that mean the 2 is? That is going to be 2 to the 1st power. You might call that an identity power, but this is the gist of today's lesson, that we can represent repeated multiplication with exponents. Okay, so there's a few different ways people say these. For example, since 2 to the 2nd, that's related to squares and square roots. We call that 2 squared. Or because we see in 3 dimensions, or maybe you have a parent who works with some measurements, and air or volume can be measured in cubic feet. This number, when you raise a number to the 3rd power, that's the same thing as cubing the number. So we're going to say this one is 2 cubed. 2 cubed. I don't have anything cubed for 4th power. But those are the ones that are typically going to be used. Now, what are some ways that it's going to be used? Geometry is one application. It says find the area of the square below. And you might already remember that area is length times width. But for a square, since all the sides are the same, we're just going to say side times side, or side, what we've just learned, to the 2nd power. Side to the 2nd power. Side squared. Maybe you're seeing a connection between the words. So, the area of this particular square would be 10 squared, or 100 square units. I'm going to put a little square like that. So, one application. One other application is being able to write numbers in expanded form. So expanded form, again, you might think, well, why do we do that? Well, it's a way to help us understand place values. So we have our ones, our tens, our hundreds, and you know this table, our thousands. I'm just going to stop here. Our 10,000s and our 100,000s. I'm going to abbreviate here a little bit. And of course, we do have some other ones here. You'll learn more about exponents in those in a future math class. But we have tenths, hundredths. I can hear the chimes. Must be windy. And then we have thousandths. Isn't that showing up? Sure it is. These are all powers of what number? Powers or exponents of what number? How can you get 10? How can you get 100? How can you get 1,000? You see, they're just ones with zeros behind them. And if you remember your divisibility rules, these are all going to stick out to you as powers of 10. So we're going to write the numbers using that fact. For example, 10 to the first is 10. 10 to the second is 10 times 10, or 100. 10 to the third is 10 times 10 times 10, or 1,000. So you see the pattern here. The exponent actually lines up with the number of zeros in the value. So if I ask you, what is 10 to the 6th equal to? You would simply write a 1 and 1, 2, 3, 4, 5, 6 zeros. And then identify the number as 1,000,000. Well, that's all nice and fun when the numbers are pretty, but we can actually use it to write a different number that's not just ones and zeros in expanded form. So take, for example, the number 2,134. How do we write that in expanded form? We have to think back. Place value. So we know that those are ones. We have tens here, hundreds here, I'm going to abbreviate, and thousands here. So here's what I'm going to do. How many thousands do I have? 2. I have 2 thousands. What is 1,000 in expanded notation or exponential notation? It's going to be 10 to the third. Now, 2,000 is then going to be added to the next place value, which is 1. I have 100. So I have 1. And then how do we write 100 with exponents? If we go back up to my little table here, there's 100 right there. We knew that was 10 times 10, or 10 to the second power. Okay, what's next? 3 tens. 10 was just 10 to the first power. So I have 3 tens. 10 to the first. And then the last one, 4 ones. Again, this is going to be a tricky one for the time because this is going to be really strange. And you won't get one like this on a test, but if we just have ones, it's actually going to be 10 to the 0. That represents my 1. If you want to just leave that off and just write the 4, that'll be okay for today. So again, just a quick recap here to make sure you make all these connections. 10 to the third was 1,000, and I had how many of those? 2. 10 to the second was 100, and I had how many of those? 1. How many more colors do I have? 10 to the first was a 10, and I had how many of those? 3. And of course, what's left? Just the ones. So for our purposes, you can just leave that number by itself. That's our number of ones. But the 0 power is a real thing, which you'll study in the future. Okay, good luck.